Welcome to Fast Math Solutions on Maths with EJD. In this video, I'll be solving this problem to differentiate f of x equals cos inverse of x. That's arc cos of x. That is what this is about. Get ready as we go on this journey. Okay. First of all, you see that f of x is given as cos inverse of x. For easier handling, you may have to make it, of course, we know y equals f of x, right? That's a general thing, that y equals f of x. Always, you can say that. So you can say y equals arc cos of x. And the way to get rid of arc cos of x is to take cos of both sides. So you have cos y equals cos of arc cos of x, so that this cancels out, and then you have cos y equals x. Now that is a feat already achieved. Can we see what else we can do? All right. So let's move on and check this out. Now, the next thing we want to do is, ultimately we need dy dx, right? So we can say we need d dx of cos y equals d dx of x. Of course, this is straightforward. We can easily do that and we get 1. But this left-hand side looks somehow. To get the dx of cos y somehow. So we can go for that to now say, okay, because this is a function of y, so we have d dy of cos y, then that has to be balanced out by multiplying by dy dx. So we can have d dy cos y dy dx, such that if you cancel dy, you still have your d dx, which you started with originally. So nothing, you have not done anything wrong, So you have d dy of cos y multiplied by dy dx to balance it out, and d dx of x is simply 1. All right. So d dy of cos y, that's just like differentiating cos y. And if you differentiate cos y, you simply get minus sine y equals, so minus sine y now, then multiplied by the dy dx you have beside it. So dy dx equals 1. Now, what you need actually is dy dx. So dy dx is actually the same thing as, so you have to divide both sides by minus sine y. So you have minus 1 over sine y. Now, what are we going to do with this? We started with just things involving x. But guess what? We have sine y here. And the way to go forward is, the last place where you saw x, before you started differentiating was cos y equals x. So you have to find a way of bringing cos y into this case. And then that reminds me that in trig, okay, let me color code that. You remember that in trig, right? The way to deal with that is, you have sine squared y plus cos squared y is equal to 1. So if you need sine y, right? If sine y is what you need, then it means that you have sine squared y equals 1 minus cos squared y. So that means that sine y alone is going to be the square root of 1 minus cos squared y. So you can come back here and, restate and write that out as what actually it is. Say dy dx equals minus 1 over sine y, you have found to be square root of 1 minus cos squared y. Don't forget, the last time you checked, cos y was x, okay? So we can bring that here. So cos y is x, right? So, this is more like dy dx equals minus 1 over square root of 1 minus cos y all squared. But you know that cos y is equal to x. So you can invoke that idea and now say that I'm spoiled for options. So okay, let me just choose black now. So then in that case, you just have dy dx is equal to minus 1 over square root of 1 minus. So cos y is x. So this is just x squared. So with this now, you have everything in terms of x. You have everything in terms of x. So you can say, therefore, um, the derivative of arc is it arccos? Is that what we have? Yeah. The derivative of okay. Okay, therefore, given that, let me do it that way. Therefore, given that f of x equals arccos of x, f prime of x will be equal to minus 1 over square root of 1 minus x squared. And that's what you have. So you want to get this kind of videos all the time. So be sure to subscribe and click on the bell button so that anytime I have a new video, you can get alerted without hesitation. See you in the next video.